So when we think about the quality of our data and we describe in our lab reports how successful we were with the experiment, what we're really thinking about is the accuracy and the level of precision of our experiments. And we really need to think about the level of accuracy and precision in our experiments, because when we analyze or we try to develop some degree of confidence in what we've said, the accuracy of our measurements and the precision that we've made those measurements with is really going to determine whether the results of the experiment are useful at all. Obviously, a very inaccurate experiment or a very imprecise experiment is probably not going to yield very useful results. So in order to use those terms correctly, I should say, you need to have definitions for these. And so you'll find there's a lot of different definitions for accuracy. There are very loose definitions, which is accuracy is the degree of closeness to the real value or the actual value. In our text, they actually define it a little more specifically as being small systematic error. So if you've eliminated this, because remember, you cannot completely eliminate the reading error or the random error, but you can certainly do something about the small systematic error. You need to eliminate it. Random error can be reduced a little bit by repeated measurements. The reading error is mostly a product of the measuring device that you use to make the measurement. So that really only leaves one error that you can actually make a measurable difference, and that is to really think carefully about how you're making your measurements. Look closely at the measuring devices. Make sure where the zero is here. Check and calibrate scales. Make sure that you calibrate things like stopwatches whenever it's possible. And so the text gives this very specific definition as accuracy being a measure of how small the systematic error is. The more accurate you are, the smaller your systematic error. You're getting closer to the true values of the device. And that's notwithstanding that you do have random and reading errors, but still the quality of your measurements is very good. The way I would define accuracy is very similar to that, but it's essentially producing a measurement, or it could be a calculation, that achieves the correct answer within a known standard. So I think that this is really the important part that's missing from the previous definition, is the idea of the fact that we're going to compare it to some known standard. And what that essentially means is that we need to decide what level do we want to measure things down to. As we've said before, you are not perfect, and certainly no measurement you make will be perfect. So there are errors in our experiments. In order to determine whether a measurement or a calculation is accurate, then we have to have some sort of standard. So a good example would be the following two measurements. If I wanted to measure the distance between Chicago and New York City, then I would probably consider that to be a pretty accurate answer if you could tell me the value within a few kilometers, within a mile or two. If you could give me the accurate distance, I would consider that to be accurate. When you even think about where in Chicago do you make your measurement to, at what point exactly? Do you go downtown? Do you go to the zero for the street signs? Do you go to town hall? Do you go to the center of the city? Where do you actually measure from? Because that actually will make a difference of a few miles. And similarly for New York, it makes up a large land area. So for me, I would consider it, you've given me an accurate measurement. If you can get me within a few kilometers, in fact, if you were off by 10 kilometers, I really wouldn't care. If I was driving from Chicago to New York, it really wouldn't have any impact. I'm more concerned about how many hundreds of kilometers is it than whether it's off by 1 or 2. By contrast, that level of uncertainty would not work for something like a computer chip, where you're talking about accuracies. You need to be accurate to within micrometers or even smaller distances. So the level of accuracy is really important, and it depends on the type of experiment you're doing.